Okay, so we're going to do a little computation here. So we have a right triangle.
Yep.
I'm zoomed out, right?
You are.
Okay. And so I'm going to call this, let's call this A, B, the whole side.
Yep, whole side is B.
And then this is B. Okay, so what relationship do we know from the Pythagorean theorem?
Let's see, we know this side here is the square root of 2a squared.
Okay, yeah, we know the length of this side, but what relationship between A and B do we know from the Pythagorean theorem?
We know, I guess we could 2b squared equals b plus a squared.
Yeah. So this side squared plus this side squared equals this side squared. So that's 2b squared equals a plus b squared. Or 2b squared equals a squared plus 2ab plus b squared. Or just simply b squared.
B squared equals a squared plus 2ab.
A squared plus 2ab. So there's some relationship between A and B here. They're not just, we can't just make them both arbitrary.
Mm-hmm.
Now, this side length here we know is B, right?
Yep, that's b.
This side length, you already told me, is square root of 2A. And so,
Square root of, yeah, 2 times a.
yeah. Which means, what is this side length?
B minus the square root of 2a.
Yeah. Okay.
Right. So
Now that's going to be complicated if we try to deal with this, actually. But we can actually, there's another relationship between this triangle with side length A and the other triangle with side length B. So what is that relationship? As we start trying to do computations with the square root of 2, so I'm trying to figure out a way to get rid of the square root of 2. So can you tell me any other place the square root of 2 appears here?
on this side, the hypotenuse here.
Okay, so what is that relationship?
So again, this side squared plus this side squared equals this side squared, or b plus a equals the square root of 2 times b.
Right, b plus a equals the square root of 2 times b, or so we can say b, the square root of 2 is b plus a over b.
Yep.
Okay, so we can fix that here. This side length is b minus, do I have room to write over here?
Yeah, you do.
B minus b plus a over b times a.
Okay.
Okay. If I get a common denominator here, this is going to be b squared minus ab
Plus
minus a squared
Yep.
over
B.
b.
B squared.
So can we figure out what b squared minus ab minus a squared equals?
Well, let's see. If you move these, if you move the a squared and 1ab to the other side, we know that it equals ab.
Aha. So this is ab over b.
And so that has to equal a.
What's a?
So that side equals A.
And that's what we were trying to prove.
Yeah.
So once we have that, we know.
We can always create a smaller triangle.
With integer sides.
Mhm.
And why do I know we have integer sides to begin with?
Well, that's what we assumed.
Okay. And then how do I know A is an integer?
If you assumed that as well.
Almost. We're almost out of battery. So we assume this is an integer, A plus B, and I just took away B.
Yeah.
Okay. So now for the last video, we're going to go back to the original geometry.